A reel of thread in the form of a solid cylinder of mass m and radius r is allowed to unroll by holding the loose end of the thread in hand. Find the acceleration with which the reel falls down. Here the thread reel is allowed to unroll itself by keeping the free end in the hand. With what acceleration the reel falls down or unrolls down. So let us consider a thread reel is a solid cylinder. So thread is present on the solid cylinder, and this is the free end. Let us say we are holding the free end at this point and you are allowing the cylinder to roll down. So definitely it rolls or rotates about this central axis. This is the axis about which the cylinder is going to rotate. We know that moment of inertia of a solid cylinder about the central axis mr square by 2. So if I compare it with beta mr square, beta becomes equal to 1 by 2. Question is with what acceleration it rolls down. If I imagine it is present on the inclined plane, let us say body is on the inclined plane and starts unrolling or rotating down. We know that A is given by g sin theta by 1 plus beta. Now this thread reel case I can imagine it as theta is 90 degree. So let us say you make this plane, this part like this. Imagine the bench is or the inclined plane is lifted so that this is 90 degree. Then thread reel is falling vertically down. So I can take the case of theta is equal to 90 degree. Therefore A becomes equal to g by 1 plus beta. So it is g by 1 plus 1 by 2, nothing but 2g by 3. The acceleration with which a thread reel unrolls is 2g by 3 since the free end is in the hand.